Hi everyone. Today we are going to set up a drop weight test in ANSYS Rocky using a specific breakage model. Let's dive right in. Open and save a new project. Begin by including some useful information about the setup for those who will open this file. In this demo, the information mainly relates to the parameters of the breakage model. In the Physics tab, keep the default options. Now import the three geometries in STL format. Do not forget to change the units. Then drag and drop them into the workspace to see the assembly. You can manipulate the assembly as you prefer, and also change the colors of the background and text. In this step, we create the surface for the inlet boundary condition. In this case, it's a circular surface with given parameters. Just follow the steps or modify the size if you want. To visualize the surface, hide or use the transparency options for the walls. This is a drop weight test, so we need to create and set up that motion. Rename it accordingly, then enable a free body translation starting at 0.2 seconds. The motion direction is along the y-axis, and it's limited by the impact surface. Now assign this motion to the test weight geometry. As part of the test, set the mass of this weight to 10 kilograms, starting 0.3 meters above the impact surface. The change is automatic and will be visible in the workspace. Finally, by clicking Preview, you can view the initial position of the motion. Now it's time for the setup of the material properties. For the default boundary, keep the default values, but for the default particles, change the Young modulus. Go and check the material interaction section. Keep the default values for both material combinations. Next step, the particle definition. We will use a single particle with a polyhedron shape. The size entered here ensures that only one particle will be present in the simulation, replicating the real test condition. Check the shape setup. You can find recommended values on the Help section. Visualize the particle and change it if needed. For this demo, we will work with the previous values. Now, let's talk about the breakage model setup. The ABT10 is one of the instant fragmentation models in ANSYS Rocky. The particle breaks when a limit is exceeded. The breakage probability is calculated as a function of different quantities and input parameters. And when the particle breaks, more theories are involved to represent the fragments in size and number. Here we will use the Gaudian-Schumann model. So click on Breakage and type all the values shown before, and for the fragments, check the Gaudian-Schumann model is selected. The next step is setting the inlet boundary condition. After defining the circular surface and particle data, we now specify the mass flow rate and the time period during which it is enabled. Finally, define the solver settings. Set the total time, reduce the time step, and enable the breakage action. For this model, I'm using 10 CPU cores to run the model. It will take 5 to 10 minutes to get results. In the post-processing, you can check the results by using the time step list or the time tab. Use your mouse to rotate, pan, and zoom in and out the geometry to get a good position and observe the particle fragmentation. You can also use a contour plot. This time I select the particle size. Now let's create a graph to assess the particle size distribution after the fragmentation. Drag and drop that variable to the window. Then, click on the histogram icon and change the options. You can define the number of bins and the range for the horizontal axis. We can also obtain the fragments count in another graph. Again, create the plot and then drag and drop the variable. On the vertical axis, you can see the number of fragments. The plot also indicates the time period during which the impact occurred. And finally, let's create two plots to assess the position and speed of the falling weight during the impact. This time, select the multiplot and drag the first variable into it. Now, hold the control button while dragging the second variable. If you don't, both variables will appear in the same plot, but we want them in two separate plots. Notice that the weight didn't reach zero because of some fragments as shown. And that's all for today. See you next time.